Hi, welcome to my video on defining an exponential function. But before I begin this video, I'd like to go back and just review or go over what I did in the last video. And that is, I'm going to turn on my calculator here, and I'm going to put in the equation 1 divided by x, and I'm going to graph it. We looked at this, and you can see that the equation has two asymptotes. Is y equals 0 and x equals 0. As x goes to infinity here, this graph gets closer and closer to 0. As x moves from the right to 0, then the values of y go to positive infinity. As x goes to negative infinity, y values get closer and closer to 0. And as I move to 0 on the left side, then the y values get closer and closer to negative infinity. And you can see that the asymptotes are y equals 0 and x equals 0. I just wanted to explain that with the graphing calculator showing you the curve. So let's continue defining an exponential function. The definition of an exponential function is f of x equals a times b to the x, where a is greater than 0, b is greater than 0, base is greater than 0, and the base is not 1, and x belongs to the real numbers. You can use any values of x here as long as they're real numbers. And the base got to be, again, repeat, greater than 0 and not 1. Note, if the f of x is equal to y, so this equation can be y equals a times b to the x. So, since the base got to be greater than 0 and not 1, one possibility is to have the base between 0 and 1. So again, we're going to have a is greater than 0, a is positive. And we're going to look at when the base is 1/2. So f of x equals 1/2 to the x. So remember, the f of x is a y. So that could be the y or the f of x, your choice. So if x is 2, a half squared becomes 1/4. X is 1, half to the 1 is a half. X is 0, a half to the 0 is 1. X is negative 1, just look at that, we have a half to the negative 1, and the negative 1 exponent flips the fraction to the reciprocal of 2 to the 1, which is 2. And we have a half to the negative 2, so a negative flips the fraction to the reciprocal of 2 squared, so we get a 4. So let's plot those points. X is 2, which is right here. This is the x-axis, that's the y-axis. X is 2, y is 1/4. X is 1, y is a half. X is 0, y is 1. X is negative 1, y is 2. X is negative 2, y is 4. And you can see that I selected just these values of x, but I could select any values of x. So this curve is what we call solid, and it's continuous, and it works like this. Here it is. And the domain is all real numbers. And the asymptote is a line that the graph goes towards but don't touch. So the asymptote here is the x-axis, which is y equals 0. Notice that a is positive, so this graph is above this asymptote, so the range is y is greater than 0. Again, the domain is the x values, the range is the y values. The x-intercept is 1. When x is 0, y is, I said the x-intercept. There's no x-intercepts because all the values of y are above 0. But the y-intercept is 1. That's the point when x is 0, y is 1. So the y-intercept is 1. So as x goes to infinity, y is going to 0. As x goes to negative infinity, the y value is going to infinity. So let's look at what type of curve this is. Let's draw a line intersecting the curve at one point. So if I draw a line intersecting the curve at one point, or I can draw a line intersecting the curve at 2 points, either or, the slope of this line is negative. So that means if the slope of the line is negative, that means this curve is negative. So we say that this curve is getting smaller and smaller. The values of y are getting smaller as x goes to infinity. So we say this is a decay curve. And a decay curve, notice the base is between 0 less than b less than 1. So if the base of an exponential function is between 0 and 1, we will have a decay curve. Okay, let's move on. Now we're looking at the f of x equals a times b to the x, where a is greater than 0. That means the graph is going to go up. And the base this time is greater than 1. So let's pick the base to be greater than 1. Let's pick a 2. So the f of x equals 2 to the x. That's the same as saying y equals 2 to the x. And just to repeat, remember the base of an exponential, the base is greater than 0 and not 1. That's true for y equals a times b to the x. The base is greater than 0, not 1. So the previous page, we looked at the base, which is between 0 and 1. Now we're looking at the base, which is going to be greater than 1. So let's put a 2 into this expression, and we'll get a 4. Put a 1 into this expression. 2 to the 1 is 2. Put 0 in, we get a 1. Put a negative 1 in. 2 to the negative 1 is 1 over 2 to the 1/2. 2 to the negative 2 is 1 over 2 squared, which is 1/4. So let's plot these ordered pairs. 2 gives me a 4. 1 gives me a 2. 0 gives me a 1. Negative 1 gives me a half. Negative 2 gives me a quarter. And these are some of the points. So I'm going to shade this in. And there it is. And notice, again, the domain of any exponential is x belongs to the reals. The domain is the x values. The asymptote, again, is going to, as x goes to negative infinity, the asymptote is 0. Will not touch this x-axis. So the asymptote is y equals 0. So the range, because this is positive, the graph is going up. So the range is y is greater than 0. All y values in this graph are greater than 0. And the x-intercept, we have no, it does not cut the x-axis, so there's no x-intercept. And again, the y-intercept, when we let x equals 0 in this equation, y is 1. So that's the ordered pair, x 0, y is 1. And as x goes to infinity, the y value goes to infinity. As x goes to negative infinity, the y value goes to 0. And again, if we draw a line intersecting the curve at 1 point, or we draw a line intersecting the curve at 2 points, this line has a positive slope going up to the right. That means that this curve will have a positive slope at any point on this curve, or any 2 points on a curve with a line drawn through it. So this curve is said to be a growth curve. And a growth curve is when the base is greater than 1. So when we have an exponential equation, a times b to the x, and the base b is greater than 1, the curve will grow like this. That's because the base is greater than 1. That's because the slope of the curve at any 2 points on it, or any point on it, is a positive. The slope of the line going through those points, or point, is positive. So let's continue. Let's look at when we have the f of x equals b to the x. If 0 is less than b less than 1, then the exponential function is a, so if the base is between 0 and 1, we will have a decay curve. In other words, just draw a little grid. If the base is between 0 and 1, curve will look like this. Between 0 and 1 is a decay, because as x goes to infinity, y is going to 0. And again, just to check, if I draw a line intersecting the curve at one point, then the slope of this line is negative. So it's a decay curve. If the base is greater than 1, exponential function is a greater than 1 is a growth curve. And again, a growth curve is as I go to infinity, the y value gets higher. As I go to negative infinity, it gets closer and closer to 0. So that's a growth curve. State if the exponential function is a growth or decay. Notice the base is 3. The base 3 is greater than 1, so it's a growth. Number 2, the base is 1/4. 1/4 lies between 0 and 1, so it's a decay curve. The base is 0.2. 0.2 lies between 0 and 1, so it's a decay curve. Number 4, the base is 6. 6 is greater than 1. The base is greater than 1, so it's a growth curve. In other words, growth curve is drawn, it'll look like this. If it's a decay curve, it'll look like this. And the base right here is 10/3, and 10/3 is 3 1/3 is greater than 1, so we have a growth curve. The base here is, B is 4/5. 4/5 is between 0 and 1, so it's going to be a decay curve. And number 7, as x goes to infinity, this is approaching 0, so the base of this curve is, because of the slope, and again we draw a line, it passes, the line has a negative slope, so this is a decay curve. And this is the growth curve. Draw a line, the slope of the line is positive, so the slope of the curve is positive, so this is the growth curve. Okay, let's continue. Now let's look at the graph of the f of x. Let's see if we can get the graph here. There. The graph of f of x equals 3 to the x. State the domain, the range, the asymptote, the y-intercept, and if it's a growth or decay. So let's look at the f of x. So the f of x is the same as a y. So y. So I could have f of x or I could have a y. So if I look at 2, the f of 2, put 2 in, is 3 squared is 9. Put a 1 in, 3 to the 1 is 3. Put a 0 in, 3 to the 0 is 1. Put a negative 1 in, 3 to the negative 1 is 1/3. Put a negative 2 in, 3 to the negative 2 is 1/3 squared, which is 1/9. And if we draw this curve, 2 right here gives me a 9. So that's approximately right there. 1 will give me a 3, ordered pair. 0, 1, x is 0, y is 1. Negative 1, 1/3. Negative 1 is a 1/3. Negative 2 is a 1/9. It's just a little bit closer. And again, these are only some of the values of x. So I'm going to shade in. The curve is a continuous curve, is solid, because we will now do it for all of these values. If I can straighten this out a bit, looking like an exponential. There it is. So notice that the domain of any exponential, 3 to the x, the domain is always x belongs to the real numbers. The asymptote, again, you can see that the asymptote is y equals 0, all the values of x. As x moves to negative infinity, this y value gets smaller and smaller and smaller, going closer to 0. So the asymptote is y equals 0. The range is going upward. Again, notice that a is 1, a is positive, so the y values are greater than 0. Remember, the domain is x, the range is y. Think about an ordered pair, x, y. I often think about D is before R, domain before range. and we have a y-intercept. The y-intercept right here is 1, and that's when x is 0, y is 1. Notice there's no x-intercept, doesn't intersect the x-axis, and the curve is a growth curve. It's a growth curve. Why? Because the base is equal to 3. B is greater than 1 is a growth curve. Another reason it's a growth curve, because if I draw a line intersecting the curve at 1 point, or I can draw a line intersecting the curve at 2 points, the slope of this line is positive, so the slope of this curve is positive, so it's a growth. Now, let's take the f of x equals 3 to the x, and let's do a reflection of the f of x in the y-axis. So reflection in the y-axis is the f of negative x equals 3 to the negative x. So a reflection of any graph, any line, any equation, any cubic, any quartic, any reflection is always when you replace x with a negative x in the equation. So that means the f to the negative x is equal to 3 to the negative x is 1/3 to the x. We remove the negative and flip reciprocate the fraction. So we're going to let the g of x be this reflection. So now we're going to have the g of x is 1/3 to the x power. So let's look at the g of x, which is still the y. So let's look at the g of x is 1/3. We're going to graph this on this axis. So we're going to say x is 2, 1, 0, -1, -2. So if I take this equation, which is the g of x equals 1/3 to the x, like that. Notice in math, when you have a function notation, f of x, so notice when I say f of x, you immediately say it's 3 to the x. When I say g of x, you will see it's a 1/3 to the x. So now, because we use function notation, we can distinguish between the f of x and the g of x. But if the equation was in terms of y, and I said y equals 3x, 3 to the x, and this is y equals 1/3 to the x, then it's a little bit more confusing. But f of x and g of x, we now know the difference. Let's put a 2 in here, and 1/3 squared is 1/9. Put a 1 in, 1/3 to the 1 is 1/3. Put a 0 in, we get a 1. Put a -1 in, and 1/3 to the -1 becomes 3 to the 1, which is 3. And we put a -2 in. Notice the -2 flips the fraction to a 3, makes the exponent positive, so we get a 9. So let's graph 2 is 1/9, so 2 is 1/9. 1 is 1/3. 0 is a 1. -1 is a 3. -2 is a 9. So notice it's a reflection. So if you took this curve and reflected in the y-axis, it would come out like this. So changing x to negative x is a reflection in the y-axis. So we're illustrating this. But the domain of this function, the domain of the g of x, is still x is greater than x belongs to the reals. The asymptote is the same, y equals 0. The range is y is greater than 0. The y-intercept is 1, and that's when x is 0, y is 1. X is 0, y is 1. And there's no x-intercept. And notice this was a growth curve. By reflecting it in the y-axis, it now becomes a decay curve. Because the base is equal to 1/3 with the reflection, that means 0 is less than b less than 1, so we have a decay curve. And besides that, if I draw a line through this curve, touching it at 1 point or at 2 points, the slope of this line is negative, so this curve is negative. And it's a decay curve. Again, I repeated that here, because the base is 1/3, and that's between 0 and 1. Okay, let's continue. State if it's a growth or decay curve and give the reason according to its base. Well, we have a negative exponent. I like to remove the negative exponent. So if I make the negative x a positive x, removing the negative flips this fraction to 4/9. That means the base is 4/9. That means the base is between 0 and 1. That means that this is a decay curve. And here we have 1/6 to the negative x, so that becomes 6 to the x. Remove the negative and flips the fraction. So the base is 6, the base is greater than 1, so this is the growth curve. So when you have if you think about it, when you have a negative x as a power, then it's going to flip the base around. So if you look at this right now, you say that's 1/6. 1/6 is between 0 and 1. You say it's a decay curve, but not. When you remove the negative, it becomes a growth curve. So even though if you left the negative x here into the table of values, and when you graph it, would still make it a growth curve. So that brings us to the end of the video on defining what an exponential function is. And if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.